Hey, where? Do you have the email?
What's that? Your email? Oh, it's under Google Chrome, yeah.
There we go.
Morning. Okay, it's 6:30. We'll get started here. Code of conduct item of the week is to drive safely, defensively, and courteously. And I know most of you know that I'm a bicyclist, so I really have an interest, a vested interest in making sure everybody on the road drives that way. And I'd have to say that most people are. I don't have much trouble on my bicycle, so I think people who have problems are usually people who create problems out on a bicycle. So we're going to talk in a few minutes about rigging again, kind of an ongoing discussion. Whoops. Because rigging is obviously a fairly extensive topic for us. Corporate announcements. Larry reports to me that he has a boatload of registrations that need to be passed out. So make sure you check with him. I'm sure you've got a vehicle on these crews that needs one, right?
Yeah.
Between trailers and trucks and everything. So check with Larry. Technical tips. We're still talking about fluid mechanics and pumps. There's a lot to talk about here. A lot of interesting stuff. This week, the discussion is Bernoulli's principle, which is it was developed by this Daniel Bernoulli back in the 1700s, a Swiss mathematician and physicist. And basically, you've all heard about law of conservation of energy, about you can't really get rid of energy out of a system or add it. It's there. So the idea is that if you have in hydraulics, if you have a pressure head and a static head or an elevation head and a velocity head, each of these combined have an energy to them, and they're always constant. So you can't just go from a high energy state to a low without having a transition, a change in the system. So this is an example which makes a lot of sense when you think about it. Bump that up a little bit. So you've got a tank of water up at elevation 50, and then a line that just drains off at 0. So what happens here, you got a state of high energy, it has high elevation, static head. This would be more like a pump pressure. I don't have a pump shown here, but you high static head down to 0. Well, what happens? It moves, right? It gains velocity. The velocity head goes up. Since this essentially goes to 0, that goes very high. And interesting enough, you can actually compute what that velocity is. It's kind of a square thing, and it's divided by 2 gravity. And actually, the units all fall out perfectly because you've got basically a V, and then you divide by feet per second squared, and you have feet and elevation in feet, and it all breaks out to feet per second. So kind of cool. You can figure out at your jet what your velocity is. So why is this important? Well, one thing that this looks like is a directional drill, doesn't it? With drill steel, with fluid pushing through in a jet at the end. I'm going to change it to be a large diameter jet of 12 inches, or I'm asking here, get a question, says, can you guess the flow out of a 12-inch pipe with a velocity of that 56.75 feet per second I computed? We'll get to that at the end. But the point here is you have a high energy, high pressure, or pressure head, elevation head state, and then it goes down to 0. So all that gets converted into velocity. So there's some other interesting applications of this theory, principle, including Venturis. And the Venturis are used on mud mixing systems in addition to a variety of things. But the idea is that you have a flow going through a pipeline, and it suddenly is constricted to a small area. So what happens then? It goes faster. When it goes faster, the pressure drops. When the pressure drops, it creates a negative pressure in towards into the hopper, and it sucks in this case, the powdered bentonite in and mixes it. And Venturis are pretty common in a lot of places, and also even is measuring flow. This is kind of a fancy one here, but they're used by measuring the velocity and flow going through the pipe because they can measure the difference between the pressure on the big diameter and the little diameter, and using all that equation, anybody can figure out what the flow is, because velocity is related to flow. And then my example, if we have for the 12-inch pipe, that's 0.785 square feet in area, times that velocity is 44.6 cubic feet per second. It all comes out at 20,000 gallons a minute. So if you had a tank up there that's just letting it all loose, and remember this is without friction, kind of idealized it, no losses at the jet, no losses in the pipe, no losses at the entry point, but you'd have 20,000 gallons a minute coming out of a 12-inch pipe. So that also gets you thinking, well, if I have a water line that breaks and there's a water tower up there, that's a serious thing. And it's going to come down like that and be a real quick disaster, as we've sometimes seen. So that's just the principle, and it's kind of obvious when you think of it that way. Yeah, you have a lot of pressure, and then it converts that to a velocity. And if you think about it, also like say your garden hose, you might have 75 psi if you get real good pressure at home in the garden hose, and then once you squeeze the nozzle, the pressure drops in the hose. It all converts to velocity. Not all of it, but a lot of it. That's a pretty fancy one. We have these venturis on a lot of things, right, Larry? A lot of components, whether it's measuring any kind of hydraulics or mud or anything or water. And sometimes they just use even a plate in there and measure it at the plate, before the plate, and after the plate. So I have an update here from the I-89 Waterbury bridges on the northbound lanes. I thought this was pretty interesting because I'm kind of assuming that this could mean that the traffic in Waterbury on 89 could be getting back to normal. Would that be true? Anyone know?
Yeah, they're hoping by the end of next week.
Wouldn't that be great?
The bridges are done paving, and we're finishing the temporary off-ramp will be all next season. That northbound Waterbury off-ramp will be totally rebuilt next year.
Oh, okay.
Paving the temporary one in preparation for next spring.
Yeah,
Bridges are. He's hoping by next Friday or so.
that's good, because that's just, I don't know, everyone, myself anyway, traveling through there, it's like, you're going down to one lane and dealing with it in the slower speed just is something I'm ready for a change on that. So that's good. All right, well, that's what I got. We're going to talk about, we're going to actually have a video today on rigging?
Yep, video.
Okay, good.
So change it up a little bit. The last couple of weeks we talked about our inspections of wire, rope, chain, and synthetics. Today I got two short videos about our hitches with chain, wire, rope, and synthetics. It's good detail, kind of talk some good proper rigging techniques, the difference between the basket, the choker, the bridle setup, and basket choker, and the straight pull. So we'll get started on those.
For our purposes in this program, we'll discuss three basic rigging hitches: the single leg, the basket hitch, and the choker. The single leg hitch is the simplest. If the sling you're using, be it chain, wire, rope, or webbing, is rated for a certain load capacity, that load capacity is the maximum weight you can hang from this hitch. Exceed the capacity, and you run the risk of an accident. A single leg is simple to hook up, but it offers no load control. It's fine for very basic lifting and setting, but don't try to move a load that's suspended by a single leg, unless it's controlled by a tag line. The basket hitch distributes the load between two legs of a sling. A true vertical basket hitch has twice the capacity of a single leg sling. The catchwords there are true vertical basket hitch. This is a true vertical basket hitch. This is not. When you go from this to this, you reduce the capacity of the sling. How much you reduce it depends upon this angle. It's called the horizontal angle. Here's the horizon line. Here's the line of the sling. The angle between them is called the horizontal angle. The smaller or tighter this angle, the more you reduce the load capacity of your sling. To illustrate, the capacity of this single leg sling is 1,000 pounds. That's how much you can hang from it straight down. Take the same sling and make a basket hitch, a true basket hitch. The capacity of that same sling is now 2,000 pounds. That's double the single leg sling. Now connect both ends to a common point. You've just reduced that sling's capacity. When the horizontal angle is at 60 degrees, its capacity drops from twice that of a single leg to 1.7 times that of a single leg. When the angle is 45 degrees, it drops to 1.4 times. And when the angle is 30 degrees, it drops to 1.0 times, or the same capacity of a single leg sling. So remember that this angle, the horizontal angle, is important in determining the sling's load capacity.
So that's kind of straight and basket, and I have another one here for more of the bridle setup.
The three basic rigging hitches are the single leg, basket, and choker. Here are a few tips to remember when using any of these hitches. Choker hitches are easy and convenient, but a double wrap choker hitch is better because it increases the surface contact between the load and the hitch. More surface contact means better control. It's excellent for use on loose bundles or slippery loads. It draws the load in, increasing surface contact and helping prevent slippage. Sling capacity is measured in a straight line pull. Choker hitches do not pull in a straight line. Force develops on a choker hitch right here. The tighter this angle, the more the sling's capacity is reduced. When riggers beat the eye of a choker down to gain surface contact, they reduce the capacity of their sling. A better way to gain surface contact is to use a double wrap choker, or insert a block of wood. An easy way to form a choker is to use a shackle. This puts less stress on the sling eye. Be sure to put the pin of the shackle in the eye of the sling. Otherwise, the pin can unscrew. A convenient way to form a choker hitch with synthetics is to use a choker hook. When using a basket hitch, be sure to balance the load to prevent slippage. The legs should be an equal distance from the center of gravity. When calculating sling capacity, remember that the sling's horizontal angle influences sling capacity. Slings are rated by a straight line pull, but if the sling is angled, its capacity is reduced. For example, look at the difference in rated lift capacity between the vertical leg and the choker hitch. It's important to remember that for any sling and any hitch, the more your sling pulls on an angle, the more its capacity is reduced. Try to keep your sling angles greater than 60 degrees. This means your slings will have to be long enough. Here's a quick way to tell. If the free ends of the slings are at least as long as the distance between the two pick points, your angle is at least 60 degrees. Be aware that with four-leg slings, it is possible that 2 or 3 legs are carrying most of the load, while the other legs are simply balancing it. A tip to remember here is that when calculating a 4-leg sling, figure it as only a 2-leg sling. Let's say this scaffold weighs 1,000 pounds. Your first instinct might be to say, I've got 1,000 pounds, and I'm lifting it with 4 legs, so each leg only has to be rated at 250 pounds. That could get you into trouble, since only 2 legs are actually carrying the bulk of the load. A better practice is to adjust the length of the sling legs to share the load evenly, and figure the rigging as a 2-leg sling, each pounds. Once again, the sling's horizontal angle will also influence sling capacity. Odd-shaped loads must be carefully analyzed to prevent any part of the rigging from being overloaded. Always lift level. One technique is to use 2 legs with an adjustable 3rd leg. The load is test lifted, and the 3rd leg is adjusted until the load lifts level. The third leg can be a chain fall or a turnbuckle. You can also create an adjustable leg with a synthetic sling, a sling saver, and a specialty shackle. Moving the sling eye up or down changes the length of the sling leg. Never shorten or adjust a sling for length by knotting or twisting it. Knots reduce the strength of the sling by at least 50%. When using lift hooks, always place slings in the base of the hook to prevent tip loading and possible fouling of the latch. If the lift eye doesn't fit into the base of the hook, use a shackle. 2 or more slings may be used in the base of a hook, provided that the included angle does not exceed 90 degrees. For multiple slings, use a shackle or ring to gather them at the base of the hook. Notice in this example that the sling is rigged so that the capacity tags of the wire rope are at the top. This prevents snagging or fouling of the tags. Don't drag slings. Hook the extra slings or long ends up and out of the way, or set them on the load.
I don't really like that last technique, but a lot of good practices there.
Fall off.
Yeah, fall off and hit somebody. But a lot of good practice here. The double wrapped choker is really, really great to use out there in the field. And they had some other good, keeping the tags up high. And just, with our chains, you got to just make sure when you're using your chains, again, it's just double use 2 legs as you're working low capacity, not 4, like they said. That gets the people into some trouble. So really good techniques. Hope someone learned some things, some new rigging techniques. Again, this is very important because we do a lot of this now. We want to make sure we're keeping our rigging up to par and they're not getting damaged, in proper rigging techniques, such as you've seen in this video, is a way to make our rigging last longer. And it looks real professional out there when you guys are lifting level and you know exactly what you're doing out there, having taglines, everything. We have a nice, clean, organized job site. It really, really does look good, nice and professional. Is there anything to add with rigging today? No?
Any special lifts or something awkward or something really heavy? If you're at all uncomfortable, even if you're not, if it's something different like that, let us know.
Yeah.
We'll analyze it for you. Running. Barber.